All right, you guys, Mr. Cubic here, coming from the man cave, where all the magic happens here. We're starting chapter 12, and it's actually a pretty easy lesson today, so I'm going to actually spend some time going back and reviewing and kind of giving us a big picture. Hopefully you find today's lesson easy. It is review. It was on the test. So hopefully we get it. So today is Monday, April 27th. This was the second day we were supposed to be back. Hopefully the May 15th, 3 weeks from now, will be the correct one and we can get back for 2 weeks. So we're doing section 12.1a. I'm actually doing 3 days on 12.1, and we're talking about derooting. So we're doing page 563. 3 through 24 multiples of 3, so it's just 8 problems. So I'm going to start here with the general form of the quadratic equation. So we've been talking about quadratics a little bit, okay, but I want to talk to you what makes a quadratic equation a quadratic equation. So let me go ahead and get out of this so you can just focus on the math instead of my handsome face. All right, so quadratic equation, general form, okay. So we know that it is ax squared plus bx plus c equals 0. So that is what's called the general form of a quadratic equation. Okay, notice that to be quadratic it has to have an x squared. If I didn't have this x squared term, it would be like 3x plus 7 or something like that. And that would make it a linear equation or a line. Okay, so this is the quadratic equation. And I'm going to add something here, right? And I'm going to add a does not equal 0. Okay? If we were in class, I'd say, why can't a equal 0, right? And you guys be stumped for a few seconds, okay? And maybe somebody raises his hand. Well, if a equals 0, right, then by the zeros method, that term would drop out, and I wouldn't have an x squared term anymore. So if a was 0, that would cause me problems, right? So a does not equal 0, just to make sure. Now, all chapter 12 is we are going to learn methods for solving the quadratic equation. Okay, so that is what chapter 12 is about. Now, one thing you'll see, there's 5 methods that you need to learn. Okay, the first one you don't need to learn, right, is graphing. To do the graphing method, you have to have a graphing calculator. You can do it by hand, but it's basically harder than what we're doing. Okay, so this one, right, you're going to learn in Algebra 2, all right, when you're allowed to use your calculator. You're not going to learn it this year, okay. Derooting, we already know, okay, just so you know, in a lot of the videos, they call derooting the property of square roots, right. Factoring, you already know. We actually did this before Christmas. I made sure that we did factoring before Christmas, so we know that. And so this one, right, complete the square, that's going to be the next lesson, 12.2. We start that Thursday. And then the quadratic formula is 12.3. We're going to do that on Friday. Okay? So I hope you have all that stuff down. Okay? So today we're just going to do some examples. Sorry, I got to move some stuff. Right? We're just going to solve by derooting. You had one of these on your test, number 17, something like this, x squared equals 100. Okay, so to deroot is to take the square root of both sides. So the square root of x squared is equal to the square root of 100. You're allowed to do that so long as you do the same thing to both sides. So here you get the absolute value of x is equal to 10. Bifurcate, right? So here you get x equals 10 and x equals negative 10. So I would write my answer x equals plus or minus 10. Okay, so I have another one underneath that, another easy example, and then we'll get to some of the harder ones that you're going to see on tonight's homework. None of them are flat out hard, but just so you can know them. Tempted to stay with that maroon. I like it, but I'm going to go with whatever color this is. All right, so x squared equals 144. So d root means to take the square root of both sides. So I get the root of x squared equals the root of 144. So the absolute value of x is equal to 12. Bifurcate, but my answer is going to be x equals plus or minus 12. All right, so hopefully you found those easy, okay? Again, I would suggest that you pause this and do the examples as we go, but if you didn't on these, right, it would make a difference. So I'm going to do some harder ones. None of these, I don't think any of these is flat out hard. Okay, but let's just remember what we're learning. De-rooting, right? To de-root is to take the square root of both sides. So I have the square root of x squared is equal to the square root of 63. Okay, now I chose this one for a reason. So the easy ones are nice because they work out, but here we have root 63. That's not a perfect square. 64 is the perfect square. So 63 is not a perfect square. So here I would get the absolute value of x. And this I'm going to have to change to root 9, root 7. So I get the absolute value of x is equal to 3 root 7. So x equals plus or minus 3 root 7. Okay? So that is maybe a little bit harder problem, but it's still, you should know that. I feel pretty confident that you know that. All right, so then how can we make this tougher? Right? Maybe we could make you have to do some work before you square root. So here I could square root this right away, right? But I think it's probably going to be easier for us if I isolate that square root term. So the first thing I probably would do here is divide both sides by 5. Okay, so these guys cancel, and I get x squared is equal to 4. Then I de-root, take the square root of both sides, and I get root x squared equals root 4. So the absolute value of x equals 2. So x equals plus or minus 2. Okay? Now, for this next one, okay, we have to do a little bit more work. Now, I think you should remember, we actually learned this, right? So if we want to know the best order, right, to undo a problem, right? I want to use PEMDAS in reverse. So I want to use SADMEP. So first I want to undo any addition and subtraction. So what I'm going to do is I'm going to add 3 to both sides. And I get 3x squared equals 75. Alright, now I'm going to undo any multiplication and division. So I'm going to divide both sides by 3, and I get x squared equals 25. Now I'm going to undo any exponents. To de-root is to take the square root of both sides. So the absolute value of x is equal to 5. So x equals plus or minus 5. Okay, probably going a little faster than I need to here. I think that I just wanted you to see a lot of these problems before we went into it. So I have 2 hard ones on the back. I'll pause a little bit at the beginning and give you a chance to do them on your own. Okay, so here's the first one. Where are you? There you go. Okay, so here we added the parentheses. Okay, so I have quantity x minus 4 squared is equal to 81. Alright, so this is going to be a little different, and I'm going to actually do the bifurcate out on this. Alright, so I'm going to go with, I don't know, I'll go with the light blue. Alright, so hopefully you tried this on your own. So the first thing I would do here is deroot. So I have root x minus 4 squared is equal to root 81. Now this is where you're going to have to actually do the bifurcate out. So that means that the absolute value of x minus 4 is equal to 9. Right? Now you might be tempted to just say plus or minus or solve from here. Let's go slow here, so make sure you understand everything that's going on. Okay? So one time I solve as is. So x minus 4 equals 9. And the second time I solve by flipping the other side. So x minus 4 equals negative 9. So here I'm going to add 4 to both sides. Here I'm going to add 4 to both sides. And you can see, hopefully, that it's not just going to be plus or minus. So these cancel. And I get x equals 13. These cancel. Here I have holes versus hills. The holes win this game. So I get x equals negative 5. So my answer is addition and subtraction, multiplication, division, exponents, and parentheses. So the first thing I'm going to do is undo any addition and subtraction. So I subtract 7 from both sides. These cancel. And I get 3 times quantity, x plus 2 squared is equal to 300. Now I would undo any multiplication and division, right? So I divide both sides by 3, and I get x plus 2 quantity squared is equal to 100. Okay, now I would undo my exponentiation, right? So here I would take the square root of both sides. Alright, and I get this x plus 2 absolute value is equal to 10. So then the last thing I would do, I have to move down in a second, so I'm not sure if you can see it, is I would have to undo the parentheses, right? So that's technically this x plus 2. Well, how am I going to undo this? Bifurcate. So I'm going to go ahead, right, and split it in 2. The first time I solve it as is, x plus 2 equals 10. The second time I solve it by flipping the other sign, so I get x plus 2 equals negative 10. So now I subtract 2. Go ahead and do it to both because it's not going to change. Cancel, and I get x equals 8. Right? So here I have holes plus holes. So I get x equals negative 12. So my answer, hopefully you can see this, it's kind of x equals, it's a set. I don't have to put it in order, but I'd like to just to be careful. X equals negative 12 and positive 8. So there's a problem. That's about as hard as we're going to get tonight. Hopefully you can knock these out of the park. But if not, please email me, text me, ask me in our meeting. Tomorrow, Tuesday, will be optional, so it'll be a great time to ask a question if you don't understand something. The odd answers are in the back if you want to check yourself, so half of them have the answers in the back. I only gave you 8 of these, so hopefully you will find them easy. Stay safe, miss you, and I will talk to you tomorrow. Peace.